Well, let's do the same thing again as what we left off on. Only this time, I'm going to add just a little bit to it. So we saw before that when we're graphing, that this is the slope, whatever number is multiplied by x, and this is the y-intercept. So this time, let's just use those instead of plotting points. The y-intercept is 3, so we know that the line we will graph will hit the y-axis at 3. The slope is -3/2, and slope can also be described as rise over run. In other words, the numerator of the slope tells us how far we rise or how far we go in the y direction. And the denominator tells us how far we run or how far we go in the horizontal or x direction. The minus sign can be applied to the numerator or the denominator. It doesn't matter. I typically put it in the numerator, and that works just fine. So that means that we will be rising -3, so down 3, and then running 2. So running 2 and ending up there so that we can graph the line like that. And that's it. That is how we do it. Being able to do that in an algebra class is very useful. Again, we will graph the line, but this time the variable y is not already by itself. So we need to isolate it first. To do that, we will subtract 2x from both sides of the equation and get this. Now, what is the slope? First of all, the slope is typically represented by the variable m. The slope is the number multiplied by x. Therefore, it is -2. It is not 9. It is not always the number that appears first. It is the number multiplied by x. The y-intercept, typically represented with the variable b, is the other number, +9. So when we graph, we plot the y-intercept first at height 9, and then we use the slope of -2 to find a second point. However, the slope is only made up of the one number, -2. If we're going to do the rise over run trick, we will need a second number. Whenever that happens, just put a 1 underneath the slope, which does not change the value of it. But now we have a rise and a run. So we will rise -2, go down 2, and then run 1. So now we can graph the line. And you can always double check by plotting a couple of points the way we did in the last video. Now, what about this equation? This one only has y. It doesn't have x. I can think of it like this if I want to. Y equals 0 times x minus 6. Since 0 times x is 0, this equation is equivalent to that one. And therefore, the slope is 0, or 0/1. And the y-intercept is -6. So the y-intercept is -6 right there. And the slope is 0, meaning we rise 0 and then we run 1. And so we get a perfectly horizontal line. So the idea here is whenever you just have y in the equation, no x's, then it will be a horizontal line. And the reason for that is y is our variable that tells us how far up or down we go. In other words, it is the height variable. And what this equation says is our height is always -6. It never changes because there's no x. And so we draw a line such that the height of the line is always -6. It's always 6 feet below the x-axis. Let's try one more of these. This time the equation only has x, no y. So just as an equation with y only is always horizontal, it turns out that an equation with only x is vertical. And so we would go to x equals 5 and then draw a vertical line. And that makes sense that that would be the line because the equation says that we are looking for points that have an x coordinate equal to 5. Well, every point on this line has an x coordinate of exactly 5 because it's vertical. And that's how it goes. We've talked about the y-intercept of a line. We can also talk about the x-intercept of a line. Where does this line intercept or hit the y-axis? At 3. So the y-intercept is 3, or the coordinates of that point are 0, 3. And for the x-intercept, the line intercepts or hits the x-axis at 2, or 2, 0. And that's all we're doing there. Don't make it complicated. Now let's find the x-intercept and the y-intercept of the line, but without the graph. One thing you might have noticed in that last topic is that the x-intercept was 2, 0 and had a y-coordinate of 0 because that point was on the x-axis. And the y-intercept had an x-coordinate of 0 because that point was on the y-axis. So how can we use that to help us find the x-intercept and y-intercept of a line? I'll say it again, because x-intercepts are on the x-axis where y is 0, then that means that to find the x-intercept, we must replace y with 0. And our x-intercept is -14/9. What about the y-intercept? Y-intercepts are found on the y-axis where x is 0. So I will replace x with 0 and solve for y. And we get a y-intercept of 7/3. But again, the coordinates of the points are -14/9, 0, and 0, 7/3. That's how we do it.